Hi, everyone, and welcome to this session. My name is Julien Testut. I'm part of the product management team at Oracle. And today I'm going to talk about how we're using the Async API in our change data capture and replication product called Oracle GoldenGate. So I'm going to talk a little bit about roadmap. So this is the typical safe harbor statement that we're showing at various Oracle presentations. And then to get started, let's take a look at the agenda. So first of all, I'm going to start by setting the stage and explain what is change data capture, what does GoldenGate do, and this is going to lead us into why are we using async APIs in GoldenGate data streams, as we'll see today. In the third part of the presentation, I'm going to just show you, I'm going to walk you through the various screens and how you can set up GoldenGate to publish messages into Async API channels. And then we'll wrap up with the roadmap section. So we'll take a look at some options, and then we'll take a look at what's ahead of us from a GoldenGate standpoint with the Async APIs. So quick background, just to set the stage, make sure everybody does know, what is change data capture and what is replication. So if you look at databases in general, there are two main types of events that can happen. One, obviously everything is stored as transactions, and within those transactions, we have two very important type of events. We have DML events, which are data manipulation language. These are your inserts, your updates, your deletes, everything that impacts the data stored in database tables. And then we have DDL events. DDL events, data definition language, are the events that are altering the structure of a schema, of a table, like creating a table, deleting a table, or altering a table itself. And in relational databases, and in databases in general, all of that information is stored in what is called logs. So you have centralized loggings, like redo logs, that are storing all of the transactions as they happen. And once the data has been committed, it's stored in the logs, and at that point in time, it's durable. And at that point in time, if a disaster occurs, you can recover those events, right? Next, change data capture is all about basically capturing the change data or the data events that have been captured in the redo logs, in the database logs. So you can see a change data capture utility or service as something that's going to mine the logs or tail the logs and capture constantly the latest changes that happen at the database level. And finally, what is replication? Replication typically uses the change data capture functionality to take the latest change data, and so DDL and DML events, and it's going to send them, it's going to replicate them to downstream systems. Those downstream systems, as we'll see today, can be other databases, can also be NoSQL systems, can be files, can be lakehouses, cloud data warehouses, and other things. And so today we're talking about GoldenGate because and I talked about change data capture because GoldenGate is a change data capture technology, and it was actually one of the first change data capture technology to come to the market in the mid-90s out of the San Francisco Bay Area. That's why it's called GoldenGate. It's all about bridging different systems. And this is a technology that has been part of the Oracle portfolio since 2009. So we acquired the technology, and this is now the cornerstone of our data integration platform at Oracle. And so we have thousands of customers. And most likely today, if you have paid something online or paid something in a store with a credit card, if you've streamed some movies or some music online, you've most likely made transactions, and those transactions have most likely been replicated by GoldenGate. So it's really part of our daily lives in the backend. Even though you're not really seeing it. But and so GoldenGate today is more than just change data capture. It's more than just replication. It's a full-blown platform with replication, with change data capture, now with data streams and the Async API integration. But it's also streaming analytics. It's also some monitoring functionality, some data transformations capabilities, and so on. So now you may wonder, why Async API? So if you look back at the CDC or replication market, from the mid-90s all the way to the mid-2000s, it was all about doing replication between database systems. So OLTP to OLTP, most likely disaster recovery, high availability. But then we also started to do real-time data warehousing, so OLTP to OLAP. There was also some reporting offloading that was done between databases. Then the next decade, from like 2005 all the way to 2015, were about the emergence of massively parallel processing data warehouses like Teradata, Netezza, Exadata on the Oracle side, as well as the big data ecosystem that was growing at that time with Hadoop. And so GoldenGate naturally, also started to support those data warehouses that I talked about, but also the Hadoop ecosystem, HDFS, Hive, HBase, and so on. And in the decade we're in right now, which is basically from 2015 all the way to till now, and 2025, we're seeing that shift towards microservices, distributed architecture, and I would say cloud data sources and data targets in general. And so we're seeing that a lot of our customers are leveraging GoldenGate for use cases such as loading a lakehouse in the cloud, loading data warehouses in the cloud. But we also see obviously hybrid use cases, on-prem to cloud, cloud to on-prem, and so on. And so for us, it's just natural to start integrating the Async API at that moment, because everything in GoldenGate and everything in change data capture is typically asynchronous, right? We're capturing, but we don't have to replicate the data right away, right? We store the data temporarily, and then we can replicate it later. So it makes sense. It's an asynchronous process. It makes sense to leverage Async APIs. What we're seeing as well with our customers is a shift towards more, even sourcing type patterns, and using GoldenGate for microservices patterns like the transaction Outbox, CQRS, Saga patterns, and others. And what we're seeing too with our customers is that the data event streams, or database event streams, as we'll talk about today, are becoming like a very important part of what is called data products in general. So we see our customers interested in grabbing the latest change data from databases and also non-databases that we support on the GoldenGate side, and then wanting to replicate or distribute that change data to downstream systems. And typically they use GoldenGate with a message broker like Kafka, or like ActiveMQ or RabbitMQ. But what we do see is are some of the challenges of doing that, because something like Kafka is not transactional. So you're leaving the consumers with the burden of ensuring that the data is consistent, that the data is in the right order. And what we're seeing as well is for some of our customers that have few targets, few consumers, it's the overhead of like setting up a message broker like Kafka or MQ can be burdensome, and so it just makes sense to be able, within the change data capture framework, to be able to basically publish change data as messages in an Async API channel. And so we believe that Async API is the future of event-driven architecture, and that's why at this point we've decided to integrate with it and create what is called GoldenGate data streams. So GoldenGate data streams is a new feature in GoldenGate that's allowing our users to take the change data that GoldenGate can capture, data again coming from relational databases, but not only NoSQL systems, messaging systems like Kafka or a JMS are supported on the source side, and then providing users with the ability to expose those as Async API channels directly from GoldenGate as part of GoldenGate data streams, and then allowing anybody to basically consume the change data, subscribe to those change data events, generate code using the YAML document that we provide, and really simplify the way they implement microservices patterns like transaction Outbox, but also without requiring necessarily a message broker, because GoldenGate with the Async API can cover basically that can do that job, if I can say. So this is really simplifying the way you can consume change data events through GoldenGate. And again, we believe that leveraging Async APIs is the future of the event-driven architecture. So it just makes sense for us to adopt them. So there are like two very important use cases that I'm going to talk about today. But really, if we step back again, based on the roots of GoldenGate, it's all about connecting together data producers and data product consumers. So again, bridging with GoldenGate, creating bridges for your data. And the two main use cases that we think are relevant for GoldenGate with the Async API are going to be providing or publishing change data events so that applications can consume them. So again, publishing into Async API channels, and anybody can subscribe to those change data events and consume them, as well as loading data lakes or lake houses, and then messaging the data, doing some further analysis, for analytics and data science type use cases. So now you may wonder, why would you want to bind yourself to the data tier? Number one is for what I mentioned early on. It's when the data is committed, when the transactions are committed, that the data is durable and the data is recoverable in case of an event. So it doesn't really make sense to send data that hasn't been committed to downstream systems, because if something happens, you have to remediate that and you have to fix the data, right? So you actually achieve the lowest latency possible if you rely on committed data. And a product like GoldenGate, because it automates the change data capture and the replication, offers the least impact on the database, the lowest latency overall, and the highest level of automation, because you can basically set up everything with a few clicks or with a few lines of code if you want to use manual code. So this is really the like providing the best approach to leverage any data events from databases or from any source that GoldenGate can capture data from. And so we're going to talk about a couple of use cases in greater details. The first one that I'm going to cover is about database event streams. So we quickly talked about it at the beginning. In this pattern, you have an application on the source side that is committing data to base tables on the database. And then you have GoldenGate that is mining the log 24/7, and it's not polling the database, right? Or it's not polling the source to get the change data. It's actually directly grabbing them from the read log, and those are getting pushed into GoldenGate through its extract capability, through its change data capture capabilities. So GoldenGate will capture the change data events, and then GoldenGate data streams will basically convert those into JSON messages that we will be publishing into Async API channels, so that any downstream consumer can subscribe to those channels and start consuming the transactions that GoldenGate has published. So this is very easy for the producer, right? Because there is really not much to do. They just have to set up GoldenGate. They just have to set up the change data capture, and we'll see it's actually very simple. It's fully automated. There is very little effort to actually publish the change data into the Async API channels. There are no application changes required. And because we can publish both the DML and the DDL events and the schema of the payload, then the target consumers can then decide what they want to do with the change data that GoldenGate has published. The main drawback of that approach is that, since you're getting data directly from the base table, you might expose some of your implementation details to your consumers, which, for some purists, might not be the best option. So that's where some other patterns have come in, like the transaction outbox pattern. So I'm not going to, describe and explain what transaction outbox is. I think at this point, most likely you're already familiar with the pattern. But the idea is, once the data has been committed to the base tables, messages are committed at the same time into an outbox table. And then you typically have a message relay that is going to pull that outbox table to see if new data came in. And if new data came in, then it's going to send it to the broker. Again, ActiveMQ, RabbitMQ, or Kafka, or any, your favorite broker, if I can say. And then the consumers are going to consume the change data the data as JSON objects. Here, the main drawback of that approach is that with the message relay, you're constantly polling the database. So, either you have a pretty high latency because you don't poll all the time, or you increase the frequency, the polling frequency, but then you add more overhead on the source database, right? So, that's where actually GoldenGate can help. GoldenGate, with its change data capture capabilities, can replace the message relay, and with its new data streams capabilities, it can actually replace the message broker and any of the issues that we've talked about, like ensuring transactional consistency, the order of the transactions, and so on, that brokers like Kafka cannot handle very well. So this slide is basically the same transaction outbox pattern, but now here we're using GoldenGate for change data capture, and we're using the Async API integration with the data streams to publish the messages. So GoldenGate will be aware of the changes that have been made to the Outbox table through the logs, and those are pushed directly to GoldenGate. So lowest latency, least impact on the source database. And then GoldenGate data streams will help users expose those transactions as messages on an Async API channel that any consumer can subscribe to and start, consuming. So you're basically getting the best possible performance and user experience here, lowest latency, least impact. You're still using the Outbox pattern to ensure transactional consistency overall. So there are really almost only benefits and no drawbacks with that approach. If you didn't want to replace your message broker and only wanted to use GoldenGate for the message relay to get the data from the Outbox table, it's also possible. And obviously, we have customers that do that today. But if you want to automate everything end to end and use the Async API channels, then you use the change data capture capabilities with data streams. So how does that work in greater details? So 7 steps. On the data producer side, you decide which tables and columns you want to expose to your end users. Then you set up the change data capture extracts in GoldenGate. You do that through our administration microservice. Once you've done that, you use our distribution microservice to publish those messages into Async API channels. And then the other steps are done by the consumer. They can browse through REST or through our graphical user interface, the different channels that we publish. They can authenticate, get the YAML document, generate code from the YAML document using the code and the generators written by the community. And then they can implement, how they want to parse the transactions, and then they can consume those transactions. So let's take a look at some of those steps. And let me show you the user interface a little bit. So this is over here, the distribution microservice in GoldenGate data streams. And so we're creating a new data stream. You can see the add data stream box. There I can specify, the origin of the data. It's what we call a trail. So that's basically where the change data was stored for GoldenGate. So you pick your trail, and then from there you pick your quality of service. Do you want to send the data exactly once, at least once, at most once? And we'll see the options in a few slides. And then you just click next. In the next screen, you can filter the change data. So it's definitely possible to take one change data trail and then decide to replicate the data or distribute the data to multiple Async API channels with different filters, so that, maybe for one consumer, you're hiding some sensitive data. For another consumer, you're excluding some tables. And for another consumer, you're exposing everything. So it's possible, and you do it through the filtering abilities. And then once you're done, you just click on Create Data Stream, and the messages will start flowing into an Async API channel. The way you will connect to data streams is through WebSocket and through WebSocket Secure for the most part, so WSS. And we've developed our own client for Async API and WebSocket Secure, and we're looking at contributing it back to the community. So it's something that we have right now in our own Git repository, and that we will soon publish so that everybody can leverage our WebSocket Secure client in their own applications. So this is definitely something that we're looking forward to. We're embedding the Async API Studio within our user interface. So you're still in data streams, you're looking at the details, and you can see the Async API Studio that you're most likely familiar with. So you can look at the different payloads and the YAML documents that we publish. This is an example of the generated client code. So on the right-hand side, you can see how you connect, again, using WSS. And then on the left-hand side, there is a part about data processing right here, which is where you would plug in your own code to parse the transactions, the change data that GoldenGate would publish through Async API. And then you, as a consumer, would decide what you want to do with the transactions that we send. And here we have an example of the payload documentation. So you can see the qualified table name, you can see the operation type. Did we capture an insert, an update, or a delete? If it's an update, you will have access to the before and the after value, which is very important. And you have access to different type of payloads, records, DDL records, DML records, and so on, and the schema as well that we publish for the data consumers to consume. This is an example of the payload that we send. So if you look on the left-hand side, right here, you can see the qualified table name. That's the table from where the data is coming from. We captured an update. You have a timestamp, you have a transaction ID, and then you have the before and after value, followed here by a DDL event where we're capturing a create table, and so on. So this is the type of information that is right now in our own format that you will be able to publish as a data product producer and consume as a data product consumer. Few options, and some of them that we've already touched on a little bit: WebSocket or WebSocket Secure for the connectivity part. From a quality of service standpoint, you can do exact once, which is the default. So GoldenGate will ensure that DML and DDL events will be sent only once and exactly once to the stream, to the Async API channel. But we can also do at most once if you can handle gaps in the streaming data records, and we can do also at least once for consumers that may want to replay some of the data once in a while, so they can expect duplicated data. Now, and so those options are set by the producers. Now, there are some options that you can set at the consumer level. And the main one is you can decide from where you want to start consuming the change data. You can create, the producers can start a data stream 6 months ago. And me as a consumer, I can start to consume the change data today, now, the current time, or I can go back in time to 6 months ago when the data streams were started and process the change data from there. And the retention period is defined by the data producers. On the roadmap, we're looking at adding more formatters. Right now, we're publishing JSON records. We are looking at doing Avro, Parquet, Protobuf, Iceberg, and more. We're looking at integrating with cloud events so that the payload that we send adheres to the standard, and that's going to be easier to consume. We're looking at integrating the GoldenGate data streams with a new functionality of the Oracle database, which is called JSON Relational Duality, that allows you to define a JSON schema at the database level and keep it in sync with the base tables automatically. So that's something that we're looking at. And then we're also, as part of the GoldenGate platform, we have that component called GoldenGate Streaming Analytics that does streaming ETL. And so we're looking at publishing the output of a streaming data pipeline as an Async API channel, so that consumers don't only consume raw data, but they can also consume prepared data or transformed data. So that's it for us today. I would like to thank you everyone for your time. I hope this was useful, and I hope to see you soon. Have a great one. Bye-bye.